Hey guys, welcome back to another video. In today's video, we are going to be having a look at the computer science May-June paper that was just done a few months ago, the latest paper currently that you can find online. So this is the May-June 2021 paper, and this is paper 1. So this is the theory segment, and I've made a video, about around 2 hours 30 minutes discussing about all the chapters and everything that you need to know about this specific paper. Later on the future, I will be making another video where I'll be talking about the entire practical segment about this. So without further ado, let's just begin and let's start off with the first question. Okay, now I have my stylus with me and we are going to be going through each and every question till we finish, and I'm going to try my best to explain every question. So we start off number 1. It says that Benedict has a computer that is assigned to an internet protocol address. So this is the IP address, okay, and it's saying the IP address is something, okay, so we don't need to know that. It says the IP address is represented as denary values. Now we know in chapter 1 we talked about denary, binary, hexadecimal, so on and so forth. So a denary value is simply something that is either between 0 to 10. So that's our number system, 1 2 3 4 5 to that, and then after 10 it repeats. Sorry, it's not 10, it's 0 to 9 technically. 0 to 9, okay, because 10 is comprised of 1 and 0. If you don't understand what I'm talking about right now, go watch my previous videos. You will understand everything with what denary is, binary is. So I'd advise you not to just jump into the past papers. That's what many students do these days, just jump into past papers without even understanding the concept. Okay, so I'd advise you to watch that entire video about chapter 1. Okay, it's in my channel. You can go and find it. I believe it's the first video actually of my channel, so go ahead and have a look at that. So right here it says that convert the denary values 167 and 214 from IP addresses to an 8-bit binary. So the first one, we are converting 167. So what I usually do is start from 1 2 4 8 16 32 64 128. okay, those are the numbers you need to remember, and simply what I'm doing is just 2 to the power 0, 2 to the power 1, 2 to the power 2, 2 to the power 3, 2 to the power 4, something like that. Okay, that's what I'm doing. I'm just listing all those numbers, but now it's in my head, so I don't even need to do the other way. So 1 2 4 8 16 32 64. I have to make what? 164. I have to make 164. So what can I do? Okay, let's start off by maybe adding 128. So what is 128 plus 64? Let's do that first. 12 39 192. So it's above 167, right? So we're not going to add that, so we're going to write 0 here. We're going to do 128 plus 32 is how much? 60. 160. Yeah, so we're going to do this. Now remember, we need 7 more. Okay, so I'll just do 4 2 and 1. Yeah, so 0 1 1 1. Okay, so there you go, done. That is the first one. So the first one is 1 0 1 0 0 1 1 1. Okay, that should be correct. Let's move on to the next one. I'll use the same thing, just do it above. Okay, let's start. So we can do, wait, what's 128 times 2 again? 256, I believe. Yeah, 256. Okay, so that's above, so we don't need to know that. Okay, so let's see. So we're gonna do 128, of course, 128. So let's do 128 plus 64 now. We should need 164 too, yeah? Yeah, we should need it. And then let's do 32, so 4, 12, 224. Okay, so we won't need 32. We'll need 16, okay? We'll need 16. I believe we need 16 because 192 plus 16 will be 8, 0, 1, 2, 208, yeah. So now we need 6 more, so we can just do 0, 1, 1, 0. And there you go, done. Okay, so here it's 1 1 0 1 0 1 1 0. If you don't understand what is happening, again, I have the video. It'll explain exactly what I'm doing right now. So in this video I'm not teaching you mainly, but it's basically guiding you. Okay, so hopefully you understand how to do that. Okay, basically what I'm doing is that with these numbers, let me do it in red. With these numbers right here, what I'm simply doing is I'm gonna take each one of them and I'm going to try to add them to this. Okay, like which numbers will give me this 167, and that's how you can do it. Okay, so that's how you do it. That's what I'm doing. Okay, the next question is saying that Benedict's computer is also assigned to something we call the media access control, the MAC address. Okay, and it says identify one similarity an IP address and MAC address has. So first of all, IP address and a MAC address. Okay, the IP addresses and the MAC addresses are used to identify something. Okay, now an IP address, we know what an IP address is. Okay, because even in the start it told us what an IP address is, right? Here, look, it told us what an IP address looks like. This is what an IP address looks like. And also, every device that is connected to the internet has an IP address. Okay, so even for example, if the device you're watching this video in has an IP address, okay, you can even go to Google and search my IP and you'll get an IP. Okay, or you can go to the settings and find your IP there. Okay, and then we have the MAC address. The MAC address is also another, address that is used to identify something. So if you've noticed something, I'm saying it is used to identify something. Okay, used to identify something. So I'm just going to write here, used to identify a computer / device. Okay, you can say way more. You can also say it's saying only one, but I'm going to say more. Okay, you can say they both are unique. Okay, both of them are unique. No one can have the same one. They're like number plates, no one can have the same. Also, they both have hexadecimal. So you can see they both have hexadecimal. Okay, so those are just some of the similarities. The differences now. The difference is the first one is that an IP address cannot be changed. An IP address cannot be changed. An IP address cannot be changed. Okay. If it is dynamic, okay, because if it is dynamic, but a MAC address, an IP address can be changed, but a MAC address cannot be changed. Okay, and the reason here I can tell you is that a MAC address is simply comprised of the manufacturer code and then the device's code, and the manufacturer code cannot be changed. Therefore, that's why it cannot be changed. But an IP address can change every time you connect it to a different network, for example, or at a different place. The IP address changes. Okay. The next difference you can say, So the next difference you can say is that an IP address does not have the manufacturer number. Let's write that. So an IP does not have a manufacturer number, while the MAC address has one. Okay, there you go. That'll give you your 2 marks right there. Okay, so that will give you your 2 marks. Let's go to number 2. It says Julia inputs personal data into a computer. Okay, so she is giving us personal data into a computer, and then she stores these 3 copies of data using the hard disk. Okay, a solid state drive and a USB. So it's a hard disk, a SSD, and a USB. Identify 3 devices that Julia can use to input personal data. So this was actually a question that was asked in a previous year, and it's just repeated. Okay, so you can just say, for example, a keyboard. So they're just looking for input device. Okay, keyboard. You can say a microphone. Okay, you can say a microphone because you're putting personal data into a computer. You can say a mouse. Okay, so simple input devices. These are just simple input devices. Okay, input devices. Okay, let's move on to the next one. The next one says that 6 statements are shown about HDDs, SSDs, and the USB. And you have to basically tick which statements. Okay, right here, the keyword, the S. See that S right there? Statements. Okay, the statements. And we have to apply it for each of the storage, and statements can apply to more than one. Okay, has no moving parts. Which ones have no moving parts? An SSD has no moving parts. USB has no moving parts. HDD has moving parts. Okay, that's why it's not that reliable. Non-volatile. They all are non-volatile. Okay, NAND gates. I believe NAND gates would be the SSD and the USB. Now this again is just, you know, theory that you need to know. Okay, this is something that you need to know, and there's no other way you can get this in the exam if you don't know, if you haven't read. Okay, so this type of question you must know. You need to know a HDD, SSD and USB. There's no other way around it. It uses magnetic properties. We know that's HDD because again it has no moving parts. It has smallest physical size. We all know this. This should be correct by all of them because we know the USB has the smallest physical size. Physical, okay? That's why it's specified, physical size. It has the smallest physical size. It has the slowest read-write speeds. So the slowest read-write speeds should be the HDD because again it has no moving parts. Okay, we move on to the next question. The next question, he says that Julia uses a USB connection. Okay, and we have to basically give the benefits. Okay, this again is another repeated question, so you can see how, you know, they keep repeating. So let's begin. The first one you can say we have high speed transmission. Okay, high speed transmission. The second one you can say is that it is automatically detected when used in a computer. Automatically detected when used in a computer. Let's move on. It says identify the type of data transmission that is used in the USB. It is serial data transmission. Serial data transmission. Okay, serial data transmission. We move on to the next question. The next question is basically filling the blanks. Okay, and it says a firewall can be used to help keep the data secure that is stored on a computer. The given paragraph describes how the firewall operates to help keep the data secure. Okay, then it's telling us complete the paragraph using the most appropriate items in the list. A firewall can be, what can a firewall be? Software or hardware? Yes. Sorry. Ooh, keeps changing, huh? So it can be software, or it can be a hardware, because usually whenever they talk about hardware, they're always talking about software. It monitors traffic between the computer and the, let's go. So we've done, let's see, the computer and the, we say network, and the network. And the network, okay, the network. Then the user sets for the traffic, the firewall will, okay, the firewall will criteria, so there you go, criteria, or sorry, have I missed something? So criteria is up here. Oh, missed the user sets criteria. So this is the criteria that is set, and the firewall will then accept or will reject the traffic based on this, and this can help prevent hacking. I think there was an option like that, hacking. Yep, hacking. So you can prevent hacking and malicious software that could be a threat to the security of the data. Okay, so let's see. Identify 3 other methods that could be used to keep the data secure. 3 other methods that could be used to keep the data secure. So let's see. Number 1, we can say use a password. Number 2, we can say the biometrics. So these are just like simple, you know, ways to keep something safe. And then we can say encryption. Okay, move on to the next question. The 2 internet risks are phishing and pharming. Describe what is meant by phishing and what is meant by pharming. Okay, so let's go. So phishing is basically a legitimate looking email, okay, that is sent to the user and redirects the user to a fake, bogus website. Okay, you can then say the intention for phishing is to steal the user's personal data. Okay, and because it's 3 marks each, that's why I'm writing all of this. So I first simply stated what the phishing email is. Second, I see what it does, and third, I did what is the consequences of this. Okay, so that's how you answer a 3-mark question. Forming would be so this is not an email, but this is a malicious code. Okay, that is downloaded, you can say downloaded into the user's computer and redirects them to a fake, bogus website, or you can just say a fake website. And then again, it is designed to obtain personal data from the user. Okay, so hopefully that was understood. That's basically how what they mean. Okay, we move on to the next question. Okay, so the next question is saying that Jamelia has a greenhouse that she uses to grow fruits and vegetables. She needs to make sure the temperature in the greenhouse stays between 25 degrees and 30 degrees, and the system has a temperature sensor and a microprocessor is used to maintain the temperature in the greenhouse. The system will, number 1, open the window and turn the heater if it becomes hot. We'll close the heater when it becomes cold. Okay, so quite simple. We have the range of 25 to 30 degrees. So if it's below 25, then it meaning it's cold, so it'll turn on the heater, and if it's more than 30, then it will sort of switch it off. Okay, so let's see. Describe how the system will use the temperature sensor. So we always start by number 1, the sensor. Okay, we'll see. Okay, we'll number these. Okay, the sensor will signal the microprocessor. Okay, number 2, we can say the data is converted from analog to digital. Now this second point is always applicable to any type of question that comes, and it's always 1 mark there. Okay, so it's an easy 1 mark. Okay, because they usually, any type of questions where it says how does the microprocessor work, you always have to name that second one. Okay, then you can say the microprocessor, even this one. Okay, even this one is, you can apply it for the question. The microprocessor will compare the value with the preset values. Okay, we move on to number 4. Number 4 says, you can say, is that now let's give us the range. Okay, so if the temperature, so if you can say if temperature is greater than 30, then the heater is switched off. Okay, then you can say number 5, the opposite. So if the temperature is less than 20 degrees, was it 20? Let me have a look. Oh, 25. Okay, so if it is less than 25, then the heater is switched on. Okay, that's simple. And then we can say, so how many is that? 5 points. Okay, let's go to 6th point. We need 8 points, remember. So then you can say if data is between 25 and 30, no action done. Okay, and then you can say number 7, actuator does the or let's say actuator switches the heater on/off. And then finally number 8, this is the easiest mark, the process is repeated. The process is repeated. Sorry, spelled that wrong. process is repeated. Okay, done. The process is repeated. So that's quite a long statement there, but that's how you sort of explain this 8-mark question. Okay, giving 8 points for this. Okay, here is a logic statement that we have to do. Okay, so let's see. So first of all, let's remind ourselves with the gates. Okay, let's remind ourselves with the gate. So we start with an AND gate. So this is how a NAND gate looks like. Okay, and then AND gate. This is how the NAND gate looks like. This is how the OR gate looks like. The NOT gate. This is how it's sort of like this. Okay, this is how the OR gate looks like. This is how the NOR gate looks like, and then this is how the XOR gate looks like. Okay, that's how the XOR gate looks like. Okay, so very bad diagrams, but hopefully you understand. Okay, so let's rub all this off, and now let's start doing this logic statement. So what I usually start with a logic statement is let's see. Okay, let's start with this. So first it's saying A and B. Okay, A and B. So we'll start there. A and B. A and B. I'm going to try to be as neat as possible actually. So let me try be as neat as possible. So you have A and you want to have B, and it's AND gate. So it's an AND gate. There you go. That's an AND gate, right? That's an AND gate. So that one right here is done. It's saying this and or C and not B. Okay, so C and not B. That basically means that we do C and then not B. So let's see. Okay, so C, we're gonna take C all the way out here, and remember B is not, right? So you do a not gate right here. Ooh, this is really not neat, and it's very hard to actually draw, but hopefully in your exam you do it not do it nicely. So here's not, and then we do and, right? Oh, that's really bad drawing. So we're doing, okay, there you go. This is there. That is and. Okay, then it's saying, so we're done with that statement, and saying it's connected by the OR gate, so we have to of course connect it. So connect it with the OR gate. The OR gate is done something like that, the OR gate, and then this OR gate is now done by the XOR not C. So XOR not C. So we have a XOR gate right here. We have a XOR gate. So here is my XOR gate, and this should be connected to X, and it is connected to a not C. So a not C will be here, not C, and now you connect the XOR gate with the not C. Okay, quite a terrible diagram, but hopefully you understand this. This is the diagram that I would do. Okay, so let's move on. And here now it says complete the truth table for the given statement. Okay, so we have to do the working space and get into this answer. Okay, so let's see. Now I'm gonna reduce the pen size to about 2. Okay, and I'm doing it with red, and what I first start with is labeling each and every gate. That's what I start with. 4, 5, 6. Okay, wow, 6. That's a big logic gate right there. Okay, and then I divide my working space into 6 parts. So 1 line, 2 line, 3 line, 4 line, 5, and then 6 will be the output. Okay, so let's start with the first one. The first one was, I believe, an AND gate, okay, of A and B. So let's do this. Okay, AND gate of A and B. So AND gate is simply multiplication, right? So 0, 0, 0, 0, 0, 0, 1, and 1. Okay, done. Let's move on to the second one. The second gate is a NOT gate of B. So it's the opposite of B. Okay, opposite of B. What's the opposite of B? 1, 1, 0, 0, 1, 1, 0, 0. Okay, opposite of the NOT gate. Number 3. Let's move on to number 3. Number 3 is an AND gate of 2 and C. Okay, of 2 and C, it's an AND gate. Of 2 and C, it's an AND gate. So let's see. It's an AND gate, so you multiply. So 0, 1, 0, 0, 0, 1. and 0, 0. Okay, let's go, easy. Number 4 is an OR gate. An OR gate is addition. So OR gate is addition of 1 and 3. So 1 and 3 addition. Let's go, 0, 1, 0, 0, 0, 1, 1, 1. Okay, there you go. Number 5. Number 5 is a NOT gate of C. So the opposite of C. So what's the opposite of C? Let's go, 1, 0, 1, 0, 1, 0, 1, 0. And finally, the last one is the 4 and 5, and this is a XOR gate. 4 and 5 XOR gate. So let me just write that down. I'll forget. Oops, sorry. 4 and 5, it's the XOR gate. Okay, 4 and 5 XOR gate. That means 0, 0 or 1, 1 will equal to 0, right? Okay, let's go. So 4 and 5. 4 and 5 is 0. Oh, have I made a mistake here? Let me see. I think I've made a mistake. Oh, okay. Okay, the next question is find the correct inputs. Okay, I was wondering because, you know, I didn't get this. Okay, so let's go. Okay, let's see. I don't know if I've made a mistake, right? Because I really don't know if I made a mistake. Yeah, I think I have made a mistake, guys. So I must have made a mistake along, you know, one of these parts right now. So yeah, it happens, you know, because of how many logic gates there are, it can happen. Surely can happen. Okay, so we'll have to do everything once again. But let me just have a look at it. 4 and 5 is connecting to 6. Yeah, 4 and 5 is connecting to 6. So we know that XOR gate, if it's 0, 0 and 1, 1, this will equal to 1, right? 0, 1 is equal to 0. Sorry, the opposite. The opposite. So like is 0, unlike is 1. Okay, should be that. Okay, so yeah, it's sort of a bit like messy right there, but let's see. Or is it? Let's see, because even row 5 is correct. Okay, yeah. Sorry, I am correct. It's just that here is 1. Okay, now it will make sense, because look, 0, 1 should be what? 1 here. 1, 1, 1, 0 should be, oh, okay, but then, yeah, it should be 1 there. That's correct. 0, 1 is 0. So here is also wrong. So here, okay, let me just rub this and explain now. Okay, yeah, I've got a mistake. Let me just do in blue. Okay, so we have to correct the mistake, right? So we have to correct the mistake. So what we simply have to do is, whenever it's 0, 1, you do, it's 1, right? Or if it's 1, 0, you do 1. And if it's like it's 0. So the first one is 0 and 1. So this is wrong. So here's the first one. It should be 1. So the first mistake. The second mistake is here at row 3. Okay, it should be another 1. Then row 4 is also wrong, because it should be 0 right here, because remember 0, 1 is 0. Okay, and then row 5 is also wrong. Okay, row 5 is also wrong. The rest are all correct. Okay, sorry, did I remove this? Yeah, it should be 0 again. Sorry, yeah, so everything was correct before. I believe everything was correct before, and yeah, should be correct. Because remember, if it's 1 and 1, then it's 0. That's correct. 1, 0 is 1. Yeah. So the answer will be row 1, 3, 4, and 5. Hopefully you've understood. You know, it's quite confusing even for me actually, because of the 6 logic gates. Okay, it's a bit confusing, but hopefully you understand now, and I think it should be correct now. Yeah, because it makes sense. Let's see if it makes sense. Because remember, when it's 1, 1, it becomes 0, which is correct. Okay. Is there any other 1, 1? Yeah, here there's a mistake. That's why it should be 0. It should be 1 here. Okay, and even here is a mistake, right? Yeah, so you've understood, hopefully. Okay, it's still a bit confusing, but it should be correct now. Hopefully you get it. Okay, so we move on. Now it says describe how the sound files are compressed using the lossless compression. So number 1 you can say is that the compression algorithm is used. Compression algorithm is used. So the compression algorithm is used, first of all. Second, you can say no data will be removed, because again it's lossless, because the original file can be restored. It will identify the repeated patterns are identified and removed. Okay, and then we can say how many do we need? We need 4, so the last one is needed. We can say let's say it is indexed. So you can say the data is indexed. Okay, there you go, that's done. Okay, so now it says state one reason why the music company would compress the sound files using lossless rather than lossy. You can say there is no loss of quality, for the sound file. Okay, number 2, give one benefit of the user. You can say what can you say? You can say quicker streaming speeds. Okay, because again it's because you're compressing. Okay, when you're compressing, you have quicker streaming speeds because of the compressed file. Okay, and then the next one is give one drawback of the music company. One drawback, so you can say it's 2 marks if you can see, so I'll have to give 2 of them. I'm not sure why it's saying 1, but I believe we should give 2. Should we? Yeah, I think we should give 2, so let's give 2. Streaming may be slower. Okay, streaming may be slower. And then you can say buffering can be caused, because when streaming slower, buffering is caused, right? Okay, the next question, it says describe how the web pages for the website are requested and displayed on a user's computer. So let's say you can say, okay, let's describe. So number 1, you have to only give 4, right? Number 1, you can say browser sends URL to the DNS. Number 2, you can say the IP address is found. Number 3, you can say browser sends request to web server. So these are just something what the web pages do for the website. And the last one, you can say security certificates are exchanged. Okay, security certificates are exchanged. Okay, we move on. Explain why this will prevent users from accessing the website. So we can say when there's a DIS, so the DOS, sorry, is simply when you give so many requests that the old server crashes. Okay, so you can say the first one, server crashes, and this is because the web server has been flooded with too many requests. Okay, we move on. Is this how many questions left? So this is the last question. Okay, last question. Let's see this one. For 7-bit binary values are transmitted. Okay, so this is a party bit. So this is the easiest question in the entire paper. All you have to do is just count the number of ones. Okay, so it's that easy. So it's saying identify whether each of the 8-bit has been sent with the odd or even. So I just count the number of ones. If it's odd, you write odd. If it's even, okay? So the first one is going to be odd because there are 3. 1, 2, 3, another odd one. 2 is even. And the last one is, sorry, let me wrap this. and the last one is 3 4, so it's even. Last one is even party. Odd odd, even. Identify why an error may not be detected with party check. So you can say it does not check. Okay, it does not check the order of the bits. Okay, it just calculates the number of ones. Okay, describe how the data is sent using parallel half duplex data transmission. So half duplex is in both directions but not at the same time, and when it's parallel it's over several wires. Okay, so you can say number one, you can say multiple bits, okay, are sent at the same time, not synchronous, not at the same, like not simultaneously, but at the same time. Uses several wires. Data sent in only both directions, if that makes sense, and but only one direction at a time. Okay, move on to the last one. It says 2 drawbacks of using parallel data transmission. So number one, you can say more expensive. So this one's it's important you know them, you need to know them. And you can also say bits may arrive skewed. Okay, that basically means not at the correct order. And there you go, that is the end of the paper. Quite a long paper, but we are done. Again, if you have any doubts with the paper, you can always feel free to comment down and I'll be ready to answer you. So thank you for watching this video. Hope you enjoyed this. I'll be making more past paper computer science videos, so stay tuned for that. Thank you for watching.